Okay, what we have here is a little project where a client wants to take a door and go to 90 to 80, but all the way to 270. So it's a very interesting application. Let's take a look and see what the client's working with. Here's a picture of, here is one of the pictures of the door. So this is the panel that the client has. There's obviously a door here, there's a door here, there's another door obviously over here. What the client wants to do is take that door, open it to 90 to 180, but then to fold it against the rear perpendicular door. That's what the client's looking to do. And we also have an image of what it looks like in the open position as well. Let's take a look at that. And here's that image as I'm looking up to see it. Just bear with me waiting for the computer to open it. Okay. All right, here we are. That's what that looks like in the open position. So right now it's an inset application. And really all that means is the door is flush with the face of the wall. So it's inset. Inset means that you've got a jamb and the door is inset this way, rather than it being overlaid or a semi or a partial inset where it's mortised in the edge. This is inset and flush. That will actually make this quite possible to do. And as I said to the client initially, it will prove impractical to do this because of what I expect to find, which is why we're using AutoCAD, is that the pivot point is going to mandate a hinge that doesn't exist. Not that this hinge couldn't be made, cut, welded, things of that nature, but that it doesn't actually exist off the shelf, so to speak. So what I'm going to do is I'm going to pause this video actually, and what we'll do here is I'm going to work up some AutoCAD work, and I will hop back into it when I've got some progress on just the general layout of what we're doing. I just want to show you what we have partially drawn here. It's just a relative, it's basically a scale version of this closet. And what we're going to want to do is take this door panel here, and we're going to want to rotate it out to 90 degrees to 180 and then back all the way around to 270 so it comes in here. So let's continue on working on that. And the next thing that we want to do is take a look at what type of hinge we would use. Well, when I saw the client's photos, what this boils down to is where the vertical axis of pivoting is to be located. So obviously that vertical axis of pivoting is going to have to be out here, somewhere right in this range right here. So let's pull up let's pull up a template of a swing clear hinge and get some basic dimensional properties of it. Okay. And we'll look at that template together. Okay, here we go. Okay, so here's a basic swing clear hinge that we can see here. And we've got some basic dimensions here in terms of where the hinge is located. Now the problem that this client will have is the door is only 13/16 thick. Well, this hinge is far too large for that. So they would have to modify their installation by adding a block to the inside face of the door so the hinge can come and get mortised to not only the edge of the 13/16, but that additional block that they would have to add to hold the door. I'm not concerned about that because the goal with this is to try to determine, can this be done we'll work on elegant later. It's an unusual request, but because of how the client wants to rotate the door, we're going to have to use as our paramount guiding principle where the vertical axis of pivoting is located. Starting with this standard hinge, this swing clear template that we're looking at on screen is where we're going to start with. The question is going to be is, as you'll see here, the 1.78 inch or the 1.687, you know, the 3/4, 8, 25, 30 seconds, the 1 in 25, 30 seconds dimension, which is what this is. How much further over that has to move? And I'm thinking it's going to have to move over a little bit, not too much, because that offset is just 4 inch on the client's. Sorry, trying to pinch that over. There we go. This dimension is 4 inch over here. So that vertical axis of pivoting is going to have to be somewhere moved over just slightly. So I'm going to take this concept of this swing clear hinge and I'm going to draw that basically in place. And I'll pause the video and I will come back when I've got more added to the drawing. Okay, so what I have drawn in here is a hinge. And here's our door. Here's our pair of doors. Okay. I've added that block that I've mentioned on the back side so that we could actually attach a swing clear hinge to it. And in order to get the door to rotate the way in which the client wants it to, we've got to move that vertical axis of pivoting way off and over here. We move it in here anywhere and it's not going to get, it's only going to go to 180 degrees. A little bit more, but not much. So let's rotate this item. What I've done is, what I'll do is I will group these objects and show you how we can rotate that. So now I have my door and half of my hinge as a group. Let's do this. Ungroup. I recognize that I didn't have the entire group added. Group, now we do. Yeah. Okay, so I have my door and the half of my hinge that's going to need to rotate added as a group. Or all of those lines created together, brought together as a group in AutoCAD. Now I'm just going to enter the rotate command, and all I need to do is select the item and then tell it what the base point is. Well, the base point is going to be the center line of the hinge pin. That's the vertical axis of pivoting. And here we are. So the door's in the closed position. And I can take that and I can rotate it out to 90 degrees, to 180 degrees. I can take that door and get it almost to 270, but I can't because the wall is not deep enough, is the problem. The limiting factor here is the offset is too great. That's actually 4.72 inch. And because my vertical axis of pivoting needs to be kicked over so far to get around the offset to bring the door to as flush as possible, because the width of the door, which frankly I'm assuming at 20 inch, and the depth of my wall is about 23.25 inch, I can really only get the door open to that jamb. So that's what I'd be able to do. If we had a narrower door, if we had a smaller offset, if we had a deeper wall depth, you know, if we had a deeper wall depth here, that's what could work. Now, what could also work is if I brought the vertical axis of pivoting out here, if I made a hinge that was bent this way, bent this way, bent this way, and then put my vertical axis of pivoting out here, the dimension required, which is probably, you know, 2 inches or so, then it would truly go to then it would truly go to 270. But this is just simply where we are. Okay, so rotate command. We're going to select our object. We're going to give it its base point, and then we can rotate. So this small AutoCAD work allows us to see visually exactly what would have to be done in order to accomplish something. And with the basic dimensions of the door width, the offset, the depth of the wall, we know exactly where things need to lay out. Now, naturally, the client's thinking about a piece of hardware that's in stock or something that's off the shelf. I'm drawing a blank to make something go 270 degrees. Again, it's all where that vertical axis of pivoting is. It's the governing of the entire operation of the door around that orbital center is what it is. So there you go. Hopefully that allows us to understand better how to move forward with coming up with a way to solve this client's problem. Thank you.